Hello, this is Mrs. Ward, and I am going to go over the final exam review take-home packet. There will be no video for the final exam review in class because we will go over that in class. Before I get started, I wanted to point out when you go to Blackboard and you click on your class, this is exactly what you will see right now. You will notice that we did open up the final exam review tab. When you click on that, you will see all the reviews. Most importantly, though, and what you should do is here is the equation sheet that you will get for the exam. You might want to open that up and see exactly what you're getting and what your formulas will look like so you know how to work with them for the exam. So this is what they look like. We are giving you the ones from Chapter 6, which is vectors, the one from Chapter 7, which is the systems. You'll notice that we have Gosh Jordan written like this, but we also took the time to rewrite it like this in the chart, which you are more familiar with. We did give you a completed unit circle. Oh my gosh. The chapter, and then all the formulas for chapter 9 with the polar equations, and then your circles, parabolas, ellipses, and hyperbolas. So everything is there. Just make sure that you look at this before the exam so you know exactly what we're providing for you, and that anything that's not on here that you come across on the review worksheet, know that you need to know that without the help of a review worksheet. All right, so let's start on, I'm going to separate this video into 3 parts so that's not so long and you can work on it as you go. So the first one is asking you to write the vector in component form. So when we do component form, we're always going to do terminal minus initial. That should have been ingrained in your head back when we did this. So I'm going to take the terminal point and subtract the initial point. And if I'm looking at this right, AB, A is going to be my initial point and B is going to be my terminal point. So to put it in component form, that's where I have the brackets. I'm going to take -3 minus the -2 and then 10 minus the -1. And when I do that, I'm going to have -1, 11, and that's the component form for that vector. Now I'm going to do PQ again, terminal minus initial, so Q is my terminal. So I'm going to take -4 minus the -6, 3 minus 6, and when I do that, I'm going to have 2, -3. In 3 and 4, they want you to write the vector as a linear combination. Remember, linear combination enters the I in the J. So the first thing I'm going to do is put it in component form. Again, terminal minus initial, so 6 minus 4, -7 minus the -4. And when I do that, I get 2, -3. So that is the component form. To write it as a linear combination, I'm going to do 2I. Since this is a minus, I'm going to write -3J. Doing AB, I'm going to do -9 minus 7, -1 minus -10. So I'm going to have -16. Whoops, almost wrote the wrong thing. And then this will be +9. Now writing it as a linear combination, this is going to be -16I plus 9J. Notice that there's no brackets, there's no comma. It's like you're adding or subtracting, and that's the proper form for linear combination. Number 5, write the magnitude of each vector. If you weren't sure, let's just check this equation sheet here. Magnitude is the double lines, and it's the square root of A plus the square root of B. So to find the magnitude of PQ, I'm going to take the square root of, well, I should put in component form first. So let me do that. Let's slide this down here first. Got a little ahead of myself. So I'm going to put in component form first. I'm going to take terminal minus initial. I'm going to have 5, -14. So I'm going to do 5 squared plus -14 squared. And when I do that, I'm going to have the square root of 221. Okay, the next one, I'm going to do the component form first. So I'm going to take terminal minus initial. So this is -1, -7. So to find the magnitude of PQ, it's going to be the square root of -1 squared plus -7 squared. And that's going to be the square root of 50. Gee, if you could actually separate that to 5 squared to 2, I would be thrilled to death. But if you can't, I guess you just can't. All right, the next one, find the component form of the resultant vector. Find the vector v that has a magnitude of 5 and is in the same direction as the vector that is given. So the first thing I'm going to do is I'm going to find the magnitude of this. So I'm going to find the magnitude of f, and that's going to be the square root of -21 squared plus -28 squared. And when I do that, that's the square root of 1,225. And I just went ahead and checked it. I did the square root of that, and it ends up being a perfect square. It ends up being 35. So I'm going to find the unit vector. So remember, the unit vector is a vector that has a magnitude of 1. So right now it has a magnitude of 35. So I'm going to divide each one of these by 35. So -21 over 35 and -28 over 35. I might want to put those in lowest terms, but I might not. I don't know. And then I want to have, so this has a magnitude of 1 right now. And I want to have a magnitude of 5, so I'm going to multiply it by 5. So I'm going to take 5 times this. And you know what? I'm just going to throw it in my calculator. I'm going to do 5 times -21 over 35. And when I put that in my calculator, I am going to get -3. And then I'm going to do 5 times -28 over 35. And I'm going to get -4. And that is the vector that has a magnitude of 5 that goes in the same direction as the original vector. So let's go ahead and try that again for number 8. First thing I'm going to do is find the magnitude of u, which would be the square root of -8 squared plus -12 squared. And you'll notice that I'm writing parentheses. Make sure if you're going to put those negative signs in that you do put them in parentheses so that you you don't mess up, I guess is the best way to say it. All right, when I do this, I get 208. That's really 16 times 13. So 4 times the square root of 13 is going to the magnitude of u. I guess if you left it as 208, I don't know what's going to happen. I have no idea, but I did 4 times the square root of 13. So now I'm going to take my original vector, which had a magnitude of -8 and -12, and I'm going to divide both of these by the square root of 13. Okay, I can't live with that. I need to simplify these. So I'm going to make this -2 over the square root of 13. And I'm going to make this -3 over the square root of 13. I just put them in lowest terms. I'm not going to rationalize yet. I'm just going to hold off on that for a second. And now I want this to have a magnitude of 5, so I'm going to multiply by 5. And when I do that, I end up getting -10 over the square root of 13 and -15 over the square root of 13. I'm going to go ahead and rationalize. And when I rationalize, remember multiplying by the square root of 13, square root of 13, I'm going to have -10 times the square root of 13 over 13 and -15 times the square root of 13 over 13. And that will be my final answer. Okay, our favorite problems. How could you forget them? The commercial jet is flying from Miami to Seattle. As soon as I see a plane, I know that I am going to have to stop and think about bearings versus unit circle angles. So in order for my vectors to work, it has to be a unit circle angle. But the way the piloting world works is that they use bearings and they don't use my unit circle angles. So when I go to do this, It says that the jet's velocity with respect to the air is 560 miles per hour, and its bearing, and it does say bearing, is 127 degrees. So to refresh your mind, when I do bearings, this is 0 degrees, this is 90 degrees, this is 180 degrees. Don't have to go any further because I'm at 127. 127 is between that 180 and 90, so it's going to be here. And this whole angle is going to be 127 degrees. In order to find the proper vector, I need this angle right here. So what I do is I take 127 and I subtract 90. And when I do that, I get 37 degrees, but since it's 37 down, this is going to be a negative 37 degrees. So to find this vector that is representing my plane that's going at a speed of 560 miles per hour, I'm going to take 560 and I'm going to multiply it by the cosine of a negative 37 degrees, sine of negative 37 degrees. And when I do that, I am going to get 447.24, negative 337.02. So that is going to be for my plane. And now it tells me, I'm going to read the rest of the problem. It tells me that the wind is blowing at the altitude of the plane is blowing from the southwest, and it's going north 45 degrees east. So let's draw that. So here's north, west, east. Remember, it spells we. It's going northeast 45 degrees. Well, this one's kind of a freebie because 45 is this angle that they mean here. But when I find if that's 45 degrees, if I take 90 and subtract 45, I'm still going to end up with 45. So the angle I'm going to use is 45 degrees. But just to be clear, I'm really using this angle, not this angle. I know they're the same, but that's the way it goes. All right, so my plane is, my wind is 45. So I'm going to take 45 times the cosine of 45 degrees, sine of 45 degrees. And I'm adding these because the plane and the wind are working together. And when I throw this in my calculator, like 45 times the sine or cosine of 45 degrees, I am going to get 31.82. And they're going to be both 31.82 because, you know, the cosine and sine of 45 are the same. Now, when I add those, when I add them together, I get what's called the resultant vector. And when I add those, when I add the 447 to the 31, I get 479.06. And when I add this, negative 337 to the positive 31, I get a negative 305.2. And you may have a few extra decimals or a few less decimals. Don't sweat that. At the end, it'll all work out. So that's my resultant vector, and I think it's going to ask me to say what is the resultant speed and direction of the plane. So it wants the speed. Remember, speed is the magnitude of the resultant vector. So I'm going to do the square root of that 479.06 squared plus that negative 305.2 squared. Biggest, most common mistake, don't forget, if you're going to put that negative sign in, you got to put in parentheses. And when I do all this, I get, and take the square root, I get 568.02 and my units for miles per hour. So that's the speed of my plane with the wind. So if I'm standing on the ground, the plane looks like it's going 568.02 miles per hour. Does it make sense? Well, yes, the plane was going 560 miles per hour. The wind is kind of pushing it along. It's kind of helping it. It's not that great of a help, so it's going to make it go 8 miles an hour faster. The next thing it wants is the direction of the plane. So I'm going to do the inverse tangent to find my angle. Remember, I'm doing my y, so that negative 305.2 over my x. And I'm putting this in my calculator to find my theta. And when I do that, my theta ends up being negative 32.5 degrees. Okay, now let's think. Negative 32.5. This is a trig angle. This is the angle that I have, negative 32.5 degrees. But it wants the direction of the plane, which is another way for saying it wants the bearing. So I want this angle coming from 0. So to go from here to here is going to be 90 degrees. And then I add another 32, and I'm going to add a positive 32 because it's 32.5 degrees further along. And I'm going to get a bearing, and I'm going to write the word bearing, of 122.5 degrees. And that is going to be the bearing of the plane. Remember, you're not going to just leave it as your trig angle. You're going to go ahead and find the bearing. Okay, moving on to the next one. It says find the projection of U onto V. Don't have a heart attack. It's on the equation sheet. Projection of U onto V is that formula right there. So I'm going to copy that down. So the projection of U onto V is given as U dot V, which remember is the dot product. And that's going to be times the magnitude of V squared. And then you multiply that by the vector B. So let's do what I have to do. So to find the projection of U onto V, I'm going to do the dot product. Remember the dot product, did you multiply the x's? So 1 times 1. And then you add the product of the y's, which is 1 times negative 4. And this is going to be over the magnitude of V, which is the square root of 1 squared plus negative 4 squared. But you're squaring that, so basically you don't need the square root sign. And then once I do get all this, I'm going to multiply it by my vector of 1, negative 4. So this will be 1 plus negative 4, which will be negative 3, over, and then this will be 17, if I did my math right. And then I'm going to do 1, negative 4. So the projection of U onto V will be negative 3/17 and a positive 12/17. And then I don't know if you remember, we did that where you had to write it as 2 orthogonal angles. Don't worry about that. We're just going to ask you for the projection of U onto V and call it a day. Okay, the next one, I'm going to do the same thing. So I'm going to do the projection of U onto V. So I'm going to do negative 3 times 9 plus negative 4 times negative 9. And this is going to be all over the magnitude of V squared. So I'm going to do the square root of negative 9 squared plus, oh, I should do positive 9 squared and negative 9 squared, same thing. And this thing is going to be squared, and then I'm going to multiply it by that vector. Hope I can squeeze that in there. So when I do that, I'm going to have negative 27 plus 36, so that will be 9. And then this will be 81 plus 81, so 162. And I'm going to multiply that by 9, negative 9. Well, this ends up being in lowest terms 1/18. And if I put in my calculator is going to tell me that. And you don't need to necessarily write all the steps, but your calculator is going to do a lot of this for you. So when I end up multiplying by 9, I'm going to end up getting 1/2 and negative 1/2, because 9 over 18 and negative 9 over 18 will be 1/2 and negative 1/2. And that is my projection of U onto V. Okay, number 12, it says find the measure of the angle between the two vectors. Ooh, so I'm going to look at my formula sheet, and the angle between two vectors is given by this cosine formula. So I'm just going to write that down. So I'm going to say the cosine of theta is equal to U dot V over the magnitude of U times the magnitude of V. So I'm going to say the cosine of theta is equal to, and then you might want to write this as negative 2, 0 and negative 7, 6 to help you out. So I'm going to do negative 2 times negative 7 plus 0 times 6 over the magnitude of U, which will be negative 2 squared plus 0 squared, which I guess I don't really have to write, but I did. And I'm going to multiply that by the square root of negative 7 squared plus 6 squared. And I'm still going to write cosine here. And when I do this, my dot product is going to be 14. And then this will end up being 2 times the square root of 85. So at this point, you can do NSolve. I'm not a big fan of NSolve, so I'm going to do the inverse cosine, and I'm going to switch these. And I am going to put that in my calculator. And give me a second. I'm not going to show you what I type in my calculator. So I have my calculator out. I'm on a calculating page. I'm going to type in what I just wrote down here, which is the inverse cosine of that 14. And just a fun fact, if this didn't end up being a perfect square, you can do the square root of like whatever this number is, like this would have been the square root of 4. You could have done the square root of 4 times 85 all underneath one radical, and that would be perfectly fine. So here I go. I'm going to do this. I'm going to go to my trig functions, inverse cosine. My favorite button is that fraction key. You should know that by now. And I am going to type in what I saw there, which I'm trying to find it. I had 14. And then in my denominator, I had 2 times, and I don't know if you know multiplication sign, but I'm just going to go ahead and put it in there. Whoops, I don't want that. Times the square root of 85. And when I do this, it's going to give me an answer. Well, that answer is in radians, so I'm going to change it to degrees. My favorite way is to go to the catalog. Right now I'm not in degrees, so I'm going to hit the D and look for the DD. And I'm going to hit enter. And once I do that DD, it'll stay with degrees decimals until I change it to something else. And I get an answer of 4.63, and that is going to be the angle between those two lines. So that's going to be 40.6. Okay, let's do the next one. So the next one, I am going to do the cosine of theta is equal to the dot product, so negative 8 times negative 1 plus negative 7 times negative 7 all over the magnitude of u, so the square root of negative 8 squared plus negative 7 squared times the square root of negative 1 squared plus negative 7 squared. And when I do this, I'm going to have 8 plus 49, which is 57. And then 64 plus 49 is 113. And then 1 plus 49 is 50. So this is what I have. So now picking up my calculator again. And I don't have to simplify any radicals. I can leave them like that. They're just a work in progress. So I'm going to do my fraction key. And then we said the dot product was 57. And then down here, I'm going to do the square root. And then it was 113. And since they're both under a radical sign, I can just do 113 times 50. I don't even have to write two different radical signs. I get this 0.711. I hit the catalog. Since I was in degree decimal last time, it's going to stay there. And I get an answer of 40.68. Oh, how funny. They're about the same. So this one is about 40. Theta will be about 40.68 degrees. And that's how I do finding the angle between two lines. Okay, the next one says write each vector in component form. So they're telling you that the magnitude is 82 and the angle is 27. So I'm just going to take the magnitude and multiply it by the cosine of 227 degrees, sine of 227 degrees. So it's kind of like before the plane problem. It's what you would do. In my calculator, I am taking 82 times the cosine of 227. I'm making sure that I put that degree symbol in. And I am going to get that vector m would equal negative 55.92 and then negative 59.97 if I round to two decimal places. All right, the next one for B, I'm going to take 59, that's my magnitude, times the cosine of 193 degrees, sine of 193 degrees. So 59 times the cosine would be negative 57.49. And then 59 times the sine would be negative 13.27. And this is my vector B. Next one is a toy wagon is pulled by exerting a force of 55 pounds on a handle that makes 17-degree angle with the horizontal. Find the work done if the wagon is pulled 100 feet. As soon as I see find the work done, when I go to my formula sheet, I'm looking for the one that says work. See how it says work right there? Work. So this is my formula. I'm taking the cosine times the magnitude times the angle. So your work is equal to the cosine of 17 degrees times the 55 times the 100 feet. All you have to do is multiply them. That's all you have to do. It's really that simple. And when I put my calculator and put all those numbers in, I get 5,259.68, and my units are foot-pounds. And that's it. Okay, so that's the last one. I know I said I was going to be due about 20, but I'm going to stop here because that ends the chapter on vectors, and I think this is a great place to stop. So this is what we did in vectors. I hope this helps, and we will see you next time in class.